Well, it's that time of year again, where we start beta testing our new CabWriter product, CabWriter 4.0. This is the first beta release of CabWriter 4, and we're anxious to get it out and have people start to use it. We've introduced a new feature. It's a sheet optimization feature. Up till now, people have had to use third-party applications to do sheet optimization and cut listing. We have included that for sheet goods and sheet good cut lists in this beta release. And I'd like to go through it today and just show you how to use it very quickly. And then as we release this, you will have something to follow and get up to speed on very quickly. And hopefully that means you'll start testing it for us. All right, I'm going to start by a little bit of review. This is the CabWriter 3 comprehensive model that I developed for the comprehensive series, video series. And it's a completed model. It's got all of the sections and elevations and what have you, and hatching and everything else. And normally what you would do at this point is you would go to File, CabWriter Production Documentation, and you would create all of the production documentation that you need for this model. And I've done that already, and so I have that. It's in a folder in the same place as the model itself, which happens to be on my desktop. So it's in a folder on my desktop right next to the model. And it has in it all of the CSV files for the cut list, all the CWX files if you were going to do a cut list plus FX export. And it has in it also all the DXF files. So nothing's changed at that point. So when you do CabWriter production documentation, you get the same results that you have in the past. But now there's a different twist. If you go to File, Cut List Bridge, you'll see something called Sheet Optimization. And if you click that, you get a new dialog box. Here it is right here. Now, I've opened this dialog box so many times during the debug cycle that I created a shortcut key. So, and you can see that right here, Cut List Bridge, Sheet Optimization. I have a shortcut key, and it's the /. So I'm going to be using that today. I just want to let you know that. So if you see that dialog box magically appear, it's because I'm using my shortcut key, which I'll use right now. And there you go. So let me explain this a little bit. First of all, up here, prior to opening this, CabWriter created the same material names and material lists that you have in Cutlass Bridge. So you have that to select from here. I'm not going to select it at the moment, but I'm just going to start describing some of these things. And for each one that you might select, you will have to specify whether or not that particular material has grain. Now, the options are yes or no, and the default is yes. Most plywood or sheet good materials have grain. Now, this is for a sheet good material name up here. This says whether it has grain. The next thing that happens when you actually select one, and I'll select something like, I don't know, maple plywood pre-finished. And notice a bunch of entries here. Now, for every one of these entries, this applies to all of these entries, whether or not it has grain. In other words, you can't have half-inch 48 by 96 plywood sheets that have grain and a 3/4 inch 48 by 96 plywood sheet that doesn't have grain. All plywood sheets with this material name have grain, or not. Here is the available sheets to be used in the cut listing and optimization process. I have half-inch 48 inch by 96, half-inch 60 inch by 120, that's 5 by 10 feet, 3/4 inch 48 by 96, and 3/4 inch 60 by 120. Now, each one of these is a little different. If I were to pick cherry plywood pre-finished, I don't have anything. And so if I didn't add something to that, the optimizer wouldn't know what to do. It wouldn't know what I want for cherry plywood pre-finished. If I have 3/4 inch material that I'm using in my project, I'd type that in here, and I could type it as 0.75 or 3/4 of an inch. Over here I can type 48 and 96. And now I can go back to my pre-finished maple plywood, come back to my pre-finished cherry, and there we go. I still have it. Now I can add other sheet formats. For instance, typically our backs are a half-inch, so I'd want to add another line for half-inch material. So I would just come down here and click Add Line, and I'd type half-inch, 48, 96, and now I can leave this and look at something else, and for the moment I'm going to look at just MDF. And the only MDF I have right now is 3/4 inch 48 by 96. But if I go back to my cherry, I now have the two formats. Notice they've been organized according to thickness. And they'll also be organized according to size. So if I look at this, notice that half-inches are grouped starting with 48 by 96 and then 60, then 3/4 48 by 96, and then 60. So they'll be organized according to size. Now suppose I want to delete one of these lines. I don't want to include that type of format in my models. Well, what I can do, is select the line I want to delete. Let's say I want to delete the 60 by 120 formats. So I can select that line and say delete line, and then I can select this line and say delete line. Okay, so that's pretty much how you set this up. Now, one of the things you need to specify is your preferred sheet format. Most of the sheets in a model are going to be 3/4 inch material. And I prefer 48 inch by 96 inch format. And I have a default of has grain. Yes. So you'd put your preferred format down here. And so when we do the optimization and layout, we'll look to see if 3/4 inch is the right thickness. If it isn't, if 1/4 inch is, if we have components in the model that are 1/4 inch, or if we have components in the model that are 1/2 inch, it will use those thicknesses, but it will put them on plywood that's 48 inches by 96, because this is my preferred format. The next thing we want to look at is some general optimization settings. This one is called Rotate Grainless Sheet Parts for Optimization. If you have MDF material in your model, you might want to set this to yes. Since there's no grain involved in MDF material, you might as well give the optimizer the permission to rotate those parts for best optimization and save some money on sheet goods. Also, if you happen to be building it out of plywood, but that plywood is going to be finished with a paint, let's say, a solid paint color, you might also want to choose this. And in fact, in that case, you might also want to choose this. This says ignore grain direction. Even though the plywood might have grain, it says pretend it doesn't. Pretend it's an MDF and just ignore it. And give permission to the router or to the optimizer to rotate any piece it wants to in order to get the best fit. So those are sort of the general selections for optimization. If you're CNCing material, and by the way, this particular release Beta 1, doesn't deal with CNC material. It only deals with the material that are on the cut list scene. Later on, we'll add capability that does optimization and viewing for parts on the DXF scene. But in this release, it's only the cut list scene. So this box really doesn't mean anything to us right now. But at a later date, you'll be able to tell it how much edge margin you want to provide. That is, if your edges might be beat up, you might want to waste 1/4 inch material all the way around the sheet and not include it in area that can be used for placing parts. Further, when you're cutting between parts, and if you've cut a part already and you're getting ready to cut one adjacent to it, you don't want to nick or resize even by a little bit the part you've already cut. So you may want a clearance. So in this case, I've specified a 1/8 inch clearance. The edge margin is for the edge margin only. The diameter of the cutter you're going to use for outside cuts shows up here in the CabWriter settings. If we look at CNC setup, notice right here, outside profile, which is, this is the bit that's going to cut the outside of a part. and it's 3/8 of an inch. So this 3/8 of an inch cutter bit would have a 1/8 inch clearance added to it for a total of 1/2 inch. And that would be the channel around parts internally. Internal channels, not margins around the edges, but internal channels. And then we can choose how we want to optimize the part. Suppose for some reason we always wanted our optimization to begin by laying things out in the X or length or X direction. Then we could choose rip cut. If we wanted to lay them out so that all the channels lined up in the width direction, we could choose cross cut. What we'd want to probably do for CNC cutting is choose optimum. That is, let the optimizer decide which to do. For CNC cutting, that's almost always the case. That's what you'll use. There's no reason to choose cross cut or rip saw or rip cut. There's that, you know, with the CNC machine that doesn't care about rip cuts or cross cuts, that would not make sense. Here's what we are interested in today: table or panel saw cutting. Again, this is the edge margin. This is the amount of material around the edges that we accept as waste, because we know the edges might be damaged a little bit. This sets the saw curve. Whatever blade you're using, you might be using the 1/8 blade, or maybe the 3/32 blade, but whatever your saw curve is, you place that in here. And then you add to it a clearance. Just like to the diameter of the cutting bit, we added a clearance here. In this case, for the saw curve, we add a clearance. And in this case, we get a 1/2 inch for internal channels. The channel along the edges will still be 1/4, but the internal channels will be 1/8 plus 1/8, whatever that is. It just happens to be 1/4, the same as the edge margin in this case. And then we choose, again, a nesting direction. Now, this does make sense when you're cutting things on a table saw or a panel saw. If your preference is that you want to handle plywood such that you make rip cuts first on a table saw, that's what you would choose. If you have a panel saw and your preference is to make cross cuts first, you would use cross cut. Or if you really don't care, and you'll do either because you really want to save money and material, you choose optimal, which is what I'm going to demonstrate now. Okay, remember when I first started out on this video, I said I had already produced the CabWriter production documentation, which included the cut list, the CSV cut list. So I'm ready to start optimization. And I do that by pushing this button. Now before I do that, let me just mention something. The moment I push this button, CabWriter is going to examine my model. It's only going to examine the parts on the cut list scene. So let me bring that scene up. These are the parts it's going to look at. Now notice in my cut list scene, I've included the door fronts and the draw fronts, the carcasses, but I haven't included, you know, any trim or anything like that, custom parts or anything like that. So at this point, what CabWriter is going to do, the very moment that I push this button, is it's going to examine all these parts, figure out which material types I need, what their thicknesses are, and how many of each we need. In other words, some of these may need the same component twice. A good example of that is this kitchen sink here. We have two doors of the same component and two Fox drawers of the same component. So it would need those twice. Some parts it would actually need more than twice, like these shelves here. And by the way, it's only going to look at sheet good material because this is a sheet good optimization. So it's going to ignore these stiles and this little rail, all these rails. So it's only going to look at the sheet goods. So it's going to figure all of that out, and then it's going to start organizing things by sheet material type and thickness. And from the time I push this button to the time the next dialog box comes up is how long it took to do the optimization. So let's just click this button and see what happens. Okay, sheet optimization is done. Now I got this blank dialog box and it's waiting for me to select a material format. So if I look at this, notice, as I said, it figured out that I'm going to need maple plywood, 3/4 inch thickness, MDF, 3/4 inch thickness, maple plywood pre-finished, 3/4 inch and 1/2 inch thickness, and shop plywood. Now you may not do cutting of shop plywood from whole sheets. That may be scrap pieces that you have in your shop, but it includes it here anyway. So now that it knows that, it's waiting for you to select one. I'm going to select 1/2 inch, no, let me select the maple plywood. The moment I do that, it populates this thing with a number of things. One is the cut list. And it's only the cut list for 3/4 inch maple plywood. And you can scroll down to see all of the parts. That's all of the parts involved with maple plywood 3/4 inch. You get the layout diagrams on a sheet by sheet basis. This is sheet 1, and that's how sheet 1 is optimized. This is sheet 2, sheet 3, and sheet 4. Now you'll notice there's a lot of white space on these sheets, and you'll ask, well, why didn't it do a better job of optimizing? Well, first of all, these are all backs. I'm sorry. Oh, this is 3/4 inch. I'm sorry, maple plywood. These are all end sheets. In end sheets, it matters the grain direction. So none of them can be rotated. And since none of them can be rotated, there aren't a lot of options to pick for some of these small spaces, because these are all fairly large parts. They can't be rotated. And so the optimizer does the best it can. And you can compare this to other optimizers and you'll see that it's very competitive. But let's take an example of where it can optimize things and rotate parts. By the way, the more parts you have of a particular type and thickness, a particular material type and thickness, the better job it can do, because it has more parts to choose from. An example of that is the maple plywood pre-finished 3/4 inch, which all of the boxes are made of. Okay, so now this is the cut list and layout for that. Notice again, this is the cut list up here, and I can scroll through. I have a lot more parts now. In fact, stepping ahead, I'll tell you that there are 233 parts I can choose from. And some of those parts These yellow parts are rotated parts. Some of the parts can be rotated to fit in spaces that are left and are small. So it can look for the smallest parts and put them in these spaces. When the optimization is done, it'll give you the results. It'll tell you the total number of instances that were placed and optimized, 233. It says it placed 233 of those 233 parts. And the total number of sheets is 23. And this is the statistics for each sheet. The sheet efficiency, how well we used the available area, and the wasted sheet. Now these numbers don't add up exactly to 100%. The reason being is, for instance, the edge margin is not available to us to put parts in. It's wasted, but it's not part of the efficiency of the tool because that's area that can't be used. So they don't add up exactly to 100%, but close. I guess in this case they did. And anyway, that's what the results are. Now, there can be cases, depending on your design, where it won't lay out all the parts. Let's choose a case here. That's not one. There we go. And notice you get some red lettering over here. It says the total number of instances is 37. It's placed 36 of 37 instances. The following instances were not placed. C2L B3 back. If I go into the model and look at that particular back, we'll find out that it is too wide for a 48-inch sheet of plywood. I'm not going to look at that. You just trust me. This part won't fit on a 48 wide sheet of plywood. And because it's a back, it can't turn it because the grain is important, so it can't rotate it. So there are times when that's the case. Now what this means is one of two things. One, you have to go back and sort of redesign things so you don't have a back or a part that doesn't fit on the plywood that you're using. Or you might choose to use a different format of plywood, either for just those parts that won't fit or for the whole project. Now, if you're dealing with table saws and panel saws, choosing a 5 by 12 or 60 by 120 inch sheet of plywood probably isn't practical, but if you're doing CNC cutting, it would be. That's very likely to be an option. In any case, it will let you know if it finds parts it can't place. And this is where you'll see that. Now the other thing is there are times when you might want to examine a part more closely. And let me go back to this. Okay, so I might want to examine this part more closely, this one right here. So if I click on it, this line gets highlighted. Now notice I only need one copy of those. But if I chose another part, let's say this one, that's not a good example. This one. If I chose this part, notice it highlights that part. I need two copies, so this is the first of those copies, and the other one will be on another sheet somewhere. And it tells me the width, which is 21 11/16. That's this dimension right here, 21 11/16. And its length is 45 5/8. That's this dimension right here. So as you look at these parts, the width is always the top left corner. I'm sorry, the length is always the top left corner, and the width is always the bottom right corner. Now, if a part gets rotated, they'll get rotated the way you would think. Now, the information here, of course, is the dimensions. This is the info here, this column right here. That tells you whether things were oversized or undersized. And there's a label. Now you have options here. For the label, you have 4 radio buttons right here. And you can choose any one of those radio buttons and it'll change the label. For instance, suppose I wanted the description of the part and the part number. I could choose that. And now notice what I actually get is the part number first and the description of the part. Part number right from here and the description right from here. If I want just the description, I can choose that. That's all I've got now is the description. I can choose just the part number. Or probably not terribly useful, but available to you is just the subassembly that it's on. Okay, so I'm going to go back to this. Now I can choose whether or not to have the dimensions on there. I can leave them off or put them on. And whether or not to have the info on there. I can leave them off or put them on with that button. Now I'm ready to preview this for a printed document. To do that, I simply push Print Preview. And it's off the screen here. I'll bring it on. This is the Print Preview screen. This is the way it'll look once it's printed out. So you have each of the sheets. All of these are going to be maple plywood pre-finished 3/4 by 48 by 96. And you'll have the page number. In this case, there's 29 pages. The reason there's 29 pages is, I believe, let's see, 6 pages are required for the cut list, and then we have 23 sheets of plywood, and those are each on a separate page. So you'll have sheet 1, maple plywood pre-finished 3/4 by 48 by 96, and that's sheet 1 right there, and then sheet 2, sheet 3, so on and so forth, all the way down until you get to the 29th sheet. So that's how you preview the printout. If you actually want to print the printout, you hit the print button. And in this case, I'm going to choose the Microsoft Print to PDF. And now I don't have to do anything else. Notice that these are best viewed in the landscape orientation. I don't have to worry about that. I don't have to go to preferences and choose landscape. CabWriter will take care of all that for me. All I have to do is hit the print button. I also don't have to tell it to print in color. CabWriter will tell it to print in color or grayscale if I'm using a black and white printer. So I'll print. Wants to know where I want to put it, and I'm going to put it on my desktop, and I'll just call it test file. And I'll say save. Now let me go to my desktop and open it up. All right, here I am. I've opened up the PDF file, but I've opened it up with Firefox. And notice that we took care of the landscape thing by actually rotating things when we sent it to the printer. Now that's a little hard to view if you want to look at these. So, but what you can do here is I can rotate this clockwise. Now I've got it on landscape orientation, and I can view it quite nicely. I could have opened this up in the Adobe Acrobat Reader, but I found this just a little more helpful. So there you are. That's the printout. Let me go back to my bottle. Here we are back at the model. And that's pretty much it. Now, what we hope to do with the next release is we'll look at the DXF scene and do the same thing. Only in the DXF scene, we will actually have to include the DXF files. We'll replace the optimized rectangles with the actual DXF files, so you'll see the actual shape of things. In other words, a part like this will show up as a rectangle currently, but once we do the DXF optimization, this will actually show up with its actual shape, as will corner cabinets. This part right here will show up with its actual shape, and any holes or pockets or anything that's in there for construction, tongues and grooves and things like that will all show up. So hopefully the next release will have that. But until then, have fun, work it over, test it out, give us any feedback you can. If there's something that's not there, that's missing, let us know, and we'll see what we can do about it. Okay, have a good day.